Question says a six-sided die in which each side is equally likely to appear is repeatedly rolled until the total of all rolls exceeds 400. Approximate the probability that this will require more than 140 rolls. Try to attempt this on your own first. I'll give you guys a minute. Okay, so we want so a dice is repeatedly rolled. Let's just assume it can continue to roll forever. So it can roll for infinite number of times. We want to approximate keyword approximate the probability that this will require more than 140 rolls. So let S be the sum of the first 140 rolls. If it requires more than 140 rolls, we wouldn't want the sum to reach 400 in the first 140 rolls. So this would be the probability of S less than or equal to. Remember that dice, the random variable of the total of dice is a discrete random variable, and we're approximating it. We will be applying the central limit theorem, but before that, we want to apply continuity correction. And we don't want it to exceed 400, but we want it can be equal to 400. So continuity correction will be as follows: S less than or equal to 400.5. Now, this is continuity correction. Now apply CLT. Recall that if X is the number rolled, then so actually the number rolled per die, then E of X equals 3.5 and variance of X equals 35/12. You may check this again for yourself if you don't remember this, but I'm just going to use them as given. They're not really hard to find. So applying CLT will give us Z being normal with mean U and standard deviation 1. We're standardizing this probability. Do that by, and we can do it as follows. So we multiply 140 with the mean and subtract it from 400.5. And then we divide it by the standard deviation of the sum of all 140 rolls. So we'll first multiply this with the variance and then take its under root. this is just equal to z being less than minus 4.43, or in other words, I of minus 4.43. You notice this won't even be on the table, so this is 0. This is approximately 0 because we were approximating the probability in the first place. In order to actually find if it's 0 or not, we're going to have to look at the actual PDF of the random variables of 140 rows instead of approximating it. So moving on to the next question. I'll give you a minute to go over it. Okay, so for question 2, it says, from past experience, the professor knows that the test score of her student taking her final examination is a random variable with mean 75. When given information, we underline it. Give an upper bound to the probability that a student's test score will exceed 85. So let's do part A first. We're given expected value of x equals 75. We want an upper bound on x being greater than 85. We're only given the mean. We don't have any idea what the random variable is like, what the distribution is like. We just know its expected value. And Markov's inequality actually tells us that. So Markov's inequality tells us that probability of any random variable x exceeding some a, this is upper bounded by its expected value divided by whatever a that you're trying to find. This is a very powerful result we will use here as well. So the probability of x exceeding 85 is upper bounded by its expected value, 75 divided by 85. This is a loose upper bound, but then again, we're just given the mean, so we can't really do much. However, in part B, we're told that in addition, the professor knows that the variance of the student's test score is equal to 25. So for B, now we know that the variance is equal to 25. What can be said about the probability that a student will score between 65 and 85? We can rewrite this as, we know the variance, we know the mean. This hints towards the Chebyshev inequality. And we can use that as follows. I'm going to rewrite this as the difference between x and 75. For Chebyshev, it's greater than 10. So in general, this is just to help you understand, Chebyshev's inequality tells us that for any x minus a being greater than some k, we have an upper bound given by the standard deviation divided by k squared. Sorry, the variance divided by k squared. And this is a tighter upper bound compared to Markov's inequality, which we expect because now we know the variance as well. So the difference between x and 75 is greater than 10. We actually want it to be less than 10 because we want it to be between 85 and 65, but we're okay with that. We can just flip the signs later. This is upper bounded by the variance squared. I'm sorry. It's upper bounded by the variance divided by k squared, which is 10 squared. And this is equal to 25 over 100, 1 by 4. Now we want 10. Sorry, we want the absolute value of x minus 75 to be less than 10. For that, we're going to have to subtract this from 1 because we're basically looking at the complement. And when we do that, this less than or equal to sign will actually change to greater than or equal to 1 minus 1 over 4, which is 3 by 4. It gives us the final answer. So 65, 85 is greater than or equal to 3 by 4. For part C, we're asked how many students would have to take the examination so as to ensure with probability at least 0.9 that the class average would be within 5 of 75. So to be within 5 of 75, we want, let me just scroll down. We want the probability of x, absolute value of x minus 75, इसका difference. To conform with Chebyshev, we're going to write greater than, लेकिन बाद में हम इसको change कर देंगे. This is upper bounded by standard deviation over pi squared. Standard deviation squared, I've made that mistake so many times. So this is, sorry, variance. I'm just going to write this as, in order to not, variance of x over pi squared. Yeah, so over here, this isn't just x. We're now looking for, what are we looking for? We're looking for the entire class, the class average. So this would be x bar. And what would the variance of x bar be? Variance of x bar equals for some n. This is how the variance is calculated for x bar. I take n outside from the denominator and I get n squared variance sum of xi's. Assuming these xi's are independent, we have of any xi, and then we're given, we can just cancel these, and the variance of each of any student divided by n. And we know that the variance of a student is 25 of the student's test scores. So we can then write this as follows. This would be 25 over n divided by 25. That's 5 squared. And this would become 1 over n. And now note that when we switch the signs, we'd have to get, so when we do this, 75 less than 5, this would be greater than or equal to, and this would be 1 minus 1 over n. And we want it to be at least greater than 0.9. For that to happen, n should be 10. So we know that n equals 10 would suffice. I hope this makes sense. Since this is recorded, you can go back and go over the entire working once again. Let's move on to the next question. It's a fairly simple one, but I'll just give you a while to go over it. Okay, so suppose that x is a random variable with mean and variance both equal to 20. What can we say about x being between 40 and 0? ये हम ऊपर इस तरह कर चुके हैं वैसे, but let's just go over this. I can write this as the x का difference 20 के साथ being greater than 20, greater than क्यों कह रहा हूँ मैं, because we know the variance, we know the mean and the variance, and we want to say something about the probability, so this should signal us towards the Chebyshev inequality. And this is then upper bounded by, so we have variance equal to 20 and k equals 20, so 20 squared. So this is just less than or equal to 1 over 20. We want the difference to be less than 20, so these signs are going to flip, and we'll have 1 minus 1 over 20, which is just equal to 19 over 20 as our final answer. So in general, Chebyshev's inequality is a stronger bound. And whenever we're given two intervals, we should think of the Chebyshev inequality if we're given the variance as well. Moving on. एक दफा attempt कर लें फिर let's go through it together. Okay, so the question says, sample of 20 cigarettes is tested to determine nicotine content and the average value observed was 1.2 mg. So the sample mean is 1.2 mg. Compute a 99% two-sided confidence interval for the mean nicotine content of a cigarette if it is known that the standard deviation of a cigarette's nicotine content is sigma is equal to 0.2. Sigma हमें पता है 0.2 है. In general, हम अगर देखें confidence intervals कैसे बनते हैं. जो हमारा point estimated है x bar, जिससे हम चाह रहे हैं कि हम म्यू के बारे में कुछ कह सकें. That's what we're trying to do, right? Where we want a confidence interval for the mean nicotine content of a cigarette. We have the sample mean. We want the true mean. We know कि जो हमारा point estimated है वो x bar. It's normal with mean, mu, and variance. So x bar is normal with mean, mu, and standard deviation sigma squared over n. तो जब हम इसको standardize करेंगे x bar को, we would get x bar minus mu over sigma divided by under root of n. सही है? And let's suppose we want some interval. Okay, 95% confidence interval होता है, so that's usually the case too. It's 1.96 and minus 1.96. And now हमने mu का interval निकालना है, so we just try to keep mu at the center. We multiply on both sides by sigma over under root n. And then we subtract x bar. क्योंकि हमारे पास minus mu है center में, we want there to be mu. हम signs swap कर देंगे. And then we should have negative से multiply करेंगे तो वो जो बीच में inequalities हैं वो भी swap हो जाएंगी. So I'm just going to flip them around. So we're just going to have x bar minus 1.96 sigma over under root n over mu less than x bar plus 1.96 sigma over under root n. ये हमारे पास इंटरवल आएगा, which gives us a 95% level of confidence that mu lies between this interval. Let me just add some space. Yeah, so इस क्वेश्चन के लिए हमें चाहिए 99% two-sided confidence interval. वो 99 के लिए जो भी z वैल्यू होगी हम उसको यूज करेंगे. ये हमारे पास एक बेसिक general form में है in which 1.96 is associated with a 95% confidence interval. But जब 99% होगा तो you would want our value to be between these. और जो ये बची हुई values होंगी, this would be alpha by 2, which is equal to 99% के लिए this should be 0.005. Same for this. And oops. And yeah, so that makes the red area equal to 99%. So for the question, yeah, we have sample mean. Yeah, the sample mean 1.2. Using the general interval we have above, I can say that mu should be between 1.2 minus some z value that corresponds to 0.005 times sigma is 0.2 and n is, we have a sample of 20, so under root of 20. This is less than mu less than 2.2 plus you can find these values in the z table, but this gives us an interval as follows: 1.0848 से लेकर 1.3152. With 99% confidence. Something to note about confidence intervals is that their boundaries are random variables. So as you change your samples, your confidence intervals will vary. This is not a probability. You will not say that mu has will occur in this interval with 0.99 probability. That's an incorrect way of interpreting it. This itself is, these intervals are random. So we know that X bar is random itself, and the sample mean will vary as you take different samples. So that's just something to keep in mind. So yeah, this is the final answer. Moving on. Take a minute to read the question. Okay, so for this question, interesting problem 13 likha hai, that just refers to the previous question. Suppose that the population variance is not known now, and the sample variance is 0.04. और उसने वही confidence interval का है कि calculate करें. अब जब population variance is not known, we basically look at the student t-distribution. और वो exactly इसी तरह की होगी जिस तरह हमने पहले किया था, but instead of the normal limits, we're going to look at the interval that looks as follows. So minus t, अब इसके होते हैं जिस उसका हमने alpha by 2 था, it's also going to have an alpha by 2. कि हम किस confidence के हिसाब से कह रहे हैं कितने degrees of freedom है, तो it should be n minus 1 degrees of freedom. So if I have 20 cigarettes in the sample, this should be 19. This is less than x bar minus mu over s square under root of n. Over here, s is the sample standard deviation. और वही इधर भी आ जाएगा. इसको we'll make mu the subject, and we should end up getting t alpha by 2 times s over under root of n less than mu, which is less than this is in general. We have our sample variance as 0.04 and we know that the mean is 1.2. We're just going to plug it all in to this whole thing. आपको टी टेबल जो है वो अवेलेबल होगा स्टूडेंट टी डिस्ट्रीब्यूशन का. You can take a look at it online as well. But once you plug the values in, you should be getting the following range. Yeah, you use the student t distribution if the variance is not 1, and you use the normal distribution if the variance is known. Mu belongs to this with 99% confidence. And just to check as well, जब हमने ऊपर निकाला था, this was 1.08482 से लेके 0848 से लेके 1.3152 तक. यहाँ पे it's 1.0720 से 1.3280 तक. This is a wider range. And that's expected because now we don't know the population standard deviation or the population variance. So yeah, moving on to problem 6, which is the last problem of this tutorial. Take a minute to read it and give it a shot. Okay, so this question says, imagine that we are trying to transmit a signal. During the transmission, there are 100 sources independently making low noise. Each source produces an amount of noise that is uniformly distributed between -1 and 1. Uniformly distributed अगर है तो मैं x y कह देता हूँ that's uniformly distributed between -1 and 1. If the total amount of noise is greater than 10 or less than -10, then it corrupts the signal. What is the probability that the signal will not be corrupted? The total amount of noise का क्या मतलब है कि the 100 sources independently making noise उनका जो sum है that should be between -10 and 10. तो ये है कि इसकी पहले हम देख लेते हैं इसका मीन क्या होगा. A plus B over 2, that's just going to be 0. इसका variance क्या होगा? And that's B minus A whole squared over 12. Yeah, you can compute that. This should turn out to be 1 over 3. And now that we know that for each random variable, we know कि 100 sources हैं. They're independently making low noise. This warrants a case for the central limit theorem. जो कि क्या कहता है कि if we multiply 100 with the mean, which is just going to be पहले मैं define कर देता हूँ. And y that's the sum 100 sources. E of y equals 0. Variance of y equals sorry, my call disconnected. So variance of y is going to be 100 over 3. And yeah, so this means standard deviation of y is just going to be 100 over 3 under root. Central limit theorem अगर हमने use करना, we want ये minus 10 और 10 के दरमियान हो, right? इसकी हमें probability चाहिए. This is going to be equal to the probability of minus 10. Expected value is 0, I'm not going to write that, divided by 100 over 3 under root. Let me make that more legible. Under root 3 less than z, less than z. अब इसमें क्या होगा? I'm just going to define that one sec. Z is normal. That means 0 and standard deviation 1. The हमने standardized कर लिया इसको. This is going to be equal to phi of 10 over under root of 100 by 3 minus phi of minus 10 over under root of 100 by 3. This would become we minus if I can do, we can just take its complement. And once we do take its complement, the whole symmetry की वजह से we can keep it positive inside phi now. Let me just explain this with a graph. तो अगर ये minus x है और हमें ये चाहिए, then if this is x, और वो phi of x जो है वो हमें ये सारा देता, then 1 minus phi of x will give us this, and this, whatever this is equal to this because they're symmetric. तो ये बन जाएगा, once we take it out of the brackets, this will become as follows, and the final answer should be 0.9164. So the probability that the signal will not be corrupted is 0.9164. That's it. I hope this helped. You can reach out to us if there are any confusions. Good luck for the quiz.